Imagine a normal evening. The moon is bright, you glance at it one last time before you fall asleep. What you don't know is it's the last time you'll ever see it again. The next evening, it's gone. No warning, no explosion, just a black patch of sky where it used to be. Within just 72 hours, things start breaking. Not because of the dark, but because almost every system on Earth has a moon quietly built into it. Everything from ocean currents to animal migrations to even the length of a year. Here's what actually happens. Tides are driven mostly by the moon's gravity. The sun accounts for only about 30% of the pull. The instant the moon disappears, most of that force is gone. But water has momentum. Billions of years of tidal rhythms don't just stop instantly. Coastlines see erratic surges in places that don't normally flood, and ports and harbors built around tidal timing stop working properly. But within a few weeks, the oceans settle into a new permanent state. Tides about 30% of their original strength, driven by the sun alone. That sounds manageable until you factor in the things that run on the old tidal cycle. Everything from coastal wetlands that filter water for hundreds of millions of people, tidal power grids, the migration timings of hundreds of marine species, and the global fishing industry built on tens of thousands of years of tidal knowledge. Sea turtles find nesting beaches by moonlight. Migratory birds time long flights to the full moon. Predators like lions, leopards, and owls hunt on schedules synced to the lunar phases. Studies have even recorded more lion attacks on humans during the dark phases of the lunar cycle when prey is harder to see. Remove the moon and every night looks like that dark phase. Coral reefs synchronize mass spawning to just one full moon a night per year. Without that lunar cue, that synchronization can break down, and reefs already in threat from heat stress can lose their main way of reproducing. Not only that, but a third of the global crop population depends on insects whose activity is cued by moonlight. Moths alone pollinate thousands of plant species bees never touch, navigating almost entirely by lunar light. Moths won't go extinct, but their navigation degrades, populations drop, and because of this, agricultural losses compound season over season. Each harvest becomes a little worse than the last. That shows up eventually as food prices, supply shortages, and stress on the food system already runs on thin margins. The fishing industry takes a second hit here too. On top of tidal disruption, many fish species breed and migrate on lunar timing. Those populations start collapsing. Earth spins on a 23.5 degree tilt. That's what gives us seasons. The moon's gravity is what keeps that tilt stable. In 1993, French astrophysicist Jacques Lescar modeled what would happen to Earth's tilt without the moon. Without it, the tilt could swing chaotically, anywhere from 0 degrees to 85 degrees over millions of years. At 0 degrees, there are no seasons. Permanent darkness at the poles, permanent heat at the equator. At 85 degrees, the Earth is nearly on its side, with the pole pointed almost directly at the sun for almost half the year. Any extreme means ice ages and heat ages far beyond anything in human history. This wouldn't happen in a human lifetime, the process is too slow, but it starts the moment the moon leaves and doesn't reverse. Every major calendar system has a moon built into it. The Islamic calendar is entirely lunar. The Hebrew calendar is lunar solar. Chinese New Year, Easter, Ramadan, all set by the lunar cycles. Months come from the moon. Sailors navigated by it, farmers planted by it. Pre-modern doctors even tracked patients by its phases. It's one of the oldest fixed reference points in human history, and it would just be gone. But you don't have to imagine this, it's already happening, just very slowly. The moon drifts 3.8 centimeters further from the Earth every year, and has since it formed 4.5 billion years ago. About 1 billion years ago, it was close enough that it made the tides run hundreds of meters high. In roughly 600 million years, it will have moved far enough that a total solar eclipse is no longer possible, because its disk will be too small to fully cover the sun. Right now, we are in the narrow window where its size is almost exactly right for that. The tides, the night brightness, the stable axis, all these things depend on where the moon happens to be right now in a process that's been running for billions of years.